All right, in this session we're going to start talking about the periodic table and how to use the periodic table to determine electrons, protons, and neutrons. Quick reminder from the first session, you need a periodic table, so if you have that periodic table of yours, go ahead and pull it out and set it off to the side as you take it. You can refer to it as we go along. Now, in the last session we talked about protons, neutrons, and electrons. All atoms of the periodic table have protons, neutrons, and electrons, but they're all a little bit different from each other. What I'm going to go ahead and do is take a big block from the periodic table, and I'm just going to pick one of them. Let's just pick sodium. The first thing I want to talk about is the lettering. Every element on the periodic table has an element symbol. Symbols are always going to be large letter, and if they have two parts, large letter and small letter. Some elements, like hydrogen, have a very logical element symbol, H. Helium, He. And so some have one letter, some have two, but you need to keep in mind the first letter is always capitalized. If there's a second letter, it's always lowercase. It is not just written smaller like that. That would be incorrect. Okay, so it has to be lowercase. Now, some of the elements have very logical symbols that go with their names, and then others, like this one, do not. Sodium, I happen to know that it came from the old term for it, which was natrium. And so Na is the lettering for it. Sometimes it comes from the Greek or Latin root word that it was originally called, especially in this case, since sodium you would think would be S. Sulfur was already S, so they went back to its original word, which was natrium, and that's why it is Na. Every element on the chart has an element symbol. And then there's numbers in the boxes. In this case, you're going to have a number like this, 11, and then 22.990. Well, let's talk about these numbers and what they're actually used for. First, this number is called the atomic number. The atomic number is the smaller of the two numbers. By definition, it is the number of protons in that atom. So in this case, sodium has 11 protons. I want you to take a second and pause the video, find the other element that has 11 protons. Now that may have been a tricky question. There is no other element on the periodic table that has 11 protons. You can find somebody next to him that has 12, or you can go back to the line before it at the very far right and find somebody that has 10. This is very important. If you know how many protons there are, you know what element it is. No other element in the world has that number of protons. So if you remember back to video 1 in your notes, it identifies the element. It sure does. 11 protons is always going to be sodium. So there is no other element that will have that number of protons. Okay, that's called the atomic number. This other number here is called the atomic mass number. The atomic mass number. Now the atomic mass number can be a little bit confusing, so let me see if I can explain this. The atomic mass number is the average mass of a sodium in the world as it is here. The average mass. Imagine that you had 10 boys, and I asked every boy how much they weighed, and I wrote it down and totaled up all their weight and divided it by 10, and I got a weight of 182.6 pounds. Does that mean that every boy weighs that? No. It's the average of all the masses. That's what this is. This decimal number is the average atomic mass of different sodiums in the world. So it's an average, that's why it's a decimal. Now, this number, for what we're going to do, is actually needs to be rounded to a whole number. So 22.990 rounds to 23. That is called the mass number. Now these words are so close, you got to be careful with them. The mass number. It's protons plus neutrons added together in the atom. So by definition, the mass number is the number of protons and neutrons added together. Now, why would that be true? Well, if you remember to the last session, protons, neutrons, electrons. Who weighed the most? Well, protons and neutrons were 1,836 times heavier than the electron. So those two things are the heaviest part of the atom, and they make up all the mass. We actually said the electrons are so light, they almost don't have any mass at all. And so here's why this is helpful to us. If this is the number of protons, and this is the number of protons and neutrons, if I subtract 23 minus 11, which is 12, that tells me that this has 12 neutrons. So there are 12 neutrons inside this atom. 23 minus 11. Then we come down to the electrons. Well, to know the number of electrons, you need to know the following piece of information. Big important star. All atoms are neutral. All atoms are neutral. And what that means is that if you have 11 protons, you have 11 electrons to equal it out. So for what we're doing right now, the proton number and the electron number are equal to each other. So let's walk through this one more time. You have 11 protons because this is the atomic number. Since you have 11 pluses to be neutral, you have to have 11 minuses. So 11 pluses and 11 minuses. And then you'll notice to get the neutrons, it is the mass number minus the atomic number. Now, what you'll find sometimes for this number right here, sometimes in some elements they're all the same number, 11, 11, 11, and others they're not. This number doesn't matter very much, it's just extra mass. Just like the example a while ago, not all the boys weigh the same, and this one has one extra neutron it looks like it may not have. And so it's just very, very normal for that element. Now I'm going to take out a couple of things. We're going to count one more together. Then I'm going to let you do a couple on your own. Here's what I want you to do on your chart. If you'll look up sulfur and look up the numbers, you'll pause the video, look up the numbers, and then we'll see what we can do with them. All right, here are the numbers that I found. Sulfur has a 16 and 32.064. Now, if you don't exactly have that number, that's okay. There's slight differences in charts, but basically you get the same answer. First thing you want to do is round this to a whole number. We're going to do that every single time. We're going to try to figure out the protons, the neutrons, and the electrons. Well, the atomic number, the smaller of the two numbers, is automatically the protons. And if you have 16 pluses, that means you're going to have 16 minuses as well to balance it out. To get the neutrons, we're going to subtract the mass number from the atomic number, 32 minus 16. You happen to have 16 neutrons as well. So sometimes you're going to have the same exact number. Sometimes your neutron number is going to vary. It really doesn't matter, but you have to do the math every single time in order to get protons, neutrons, and electrons that are found in the atom. Now remember, nobody else in the world has 16 protons. Reminder, I saw this one time on a tax test. They said they had an unknown element Q, and there's no Q on the periodic table. And they told you in the statement that it had 19 protons and 22 neutrons. You don't even have to read any further. And it asked, what element could it be? As soon as you see there's 19 protons, all you have to do is look up on the periodic table and you know that it's potassium. Because there's only one thing in the world that can be 19 protons, potassium, and that's its symbol, K. An awkward symbol, but that's the symbol for potassium. So sometimes they'll try to trick you, but as soon as you see the proton number, you immediately know what element it is. Protons, neutrons, and electrons.